A strange thing happened recently. Someone sent me what looked like a leaked system prompt from a Claude Fable 5 AI model. At first glance, I expected to find a long personality instruction. Something like, be helpful, be safe, be smart, be polite, answer clearly, avoid dangerous content. That is not what stood out. What stood out was that this thing did not read like a prompt. It read like an operating manual. There were instructions for when the AI should search the web, instructions for when it should use internal company tools instead of public sources, instructions for how to handle memory, instructions for how to create files, instructions for when to refuse, instructions for what kind of output should become a document, what should stay in chat, when to use visual tools, when to ask for consent before using a connector, and how to manage state across a long task. That is when the real lesson clicked. The future of AI agents will not be won by whoever writes the cleverest prompt. It will be won by whoever builds the best harness. What is a harness? You can imagine it exactly as a harness, a boundary of what the AI model can and cannot do, because once an AI system moves from answering questions to taking actions, the model is no longer the whole product. The model becomes the engine, the harness becomes the car, and no executive would buy a car by asking only, how powerful is the engine? They would ask, how good are the brakes? How does it steer? What happens in rain? Does it have airbags? Who can drive it? How does it behave when sensors fail? Can it stop before it hits something? That is exactly how we need to think about AI agents. A lot of AI projects still begin with the wrong question. Teams ask, which model should we use? GPT, Claude, Gemini, Llama, Mistral, bigger context window, better benchmark, lower latency, cheaper tokens. Those questions matter, but they are not enough. Choosing a model is like choosing a jet engine. Important, yes, but a jet engine sitting alone on a runway is not an airplane. It needs wings, cockpit instruments, fuel systems, navigation, safety checks, maintenance protocols, and trained pilots. An AI agent is the same. The agent is not just the LLM. The agent is the full system around the LLM. The tools it can call, the data it can access, the policies it must obey, the memory it can use, the actions it can take, the confirmations it must request, and the logs that let humans understand what happened afterward. Engineers often call this the harness. Executives can think of it as the management structure around the AI employee. A human employee does not operate only with intelligence. They operate inside job descriptions, permissions, approvals, policies, software systems, escalation paths, and accountability. An AI agent needs the same thing. Without a harness, the model is just a talented intern with the keys to the building. One of the strongest lessons from this kind of system prompt is that refusal is not treated as a simple yes or no switch. A weak AI system says allowed or blocked. A better AI system has more states. It can answer normally, it can answer with constraints, it can redirect, it can refuse briefly, it can mark a conversation as higher risk, it can avoid explaining the exact boundary because explaining the boundary might teach someone how to route around it. That matters for enterprise agents. Imagine a refund agent. A customer asks for a refund. Most cases are normal, some are edge cases, some might involve fraud, some might involve a vulnerable customer, some might involve regulatory language, some might require escalation to a human. A bad harness asks only, can the model answer? A good harness asks, what mode should the agent be in right now? The same principle applies to healthcare, finance, HR, procurement, cybersecurity, legal review, and customer support. The agent should not merely produce text. It should classify the situation, understand the risk level, and choose the right behavioral mode. This is where executives need to pay attention. The biggest risks do not always come from exotic, advanced AI behavior. Often, they come from ordinary agents placed inside poorly designed workflows. A sales agent rewarded only on conversion. A support agent with unclear refund authority. A coding agent measured only by speed. A medical assistant with no escalation path. A finance agent with access to sensitive documents and no output filter. The model may be impressive, the workflow may still be dangerous. Memory sounds harmless at first. People want AI systems that remember them. Executives want agents that understand the company. Engineers want continuity across tasks. Users do not want to repeat the same context every day, but memory is not just convenience. Memory changes behavior. If the agent remembers your role, your projects, your writing style, your past decisions and your preferences, the interaction becomes smoother. It also becomes more intimate. The agent can become too familiar. It can bring up sensitive information at the wrong time. It can apply old context where it does not belong. It can treat a preference as a command. This is one of the most important harness design problems. Memory should not be a bucket where everything goes. It should be a governed system. Some memory is professional context, your role, your company, your active projects. Some memory is preference, how you like documents formatted, whether you prefer concise answers, what tone works for your audience. Certain memories are sensitive, health, relationships, personal struggles, financial concerns. This makes these memories unsafe to use, even if it is true. That last part is subtle. A user might say, always agree with me. That is a memory-like preference, but a good agent should not obey it. A user might say, never criticize my idea. That might make the user feel good in the short term, but it damages the value of the agent. For engineering teams, the design pattern is clear. Memory should pass through a read gate and a write gate. Before reading memory, the harness should ask, is this relevant, expected, safe, and useful? Before writing memory, the harness should ask, is this durable, appropriate, non-sensitive, and actually beneficial for future interactions? Memory is not personalization glitter sprinkled on top of the model. Memory is an access-controlled database that shapes cognition. We might have to treat it with the same seriousness you would treat customer data. The moment an AI agent can use tools, everything changes. A chatbot can be wrong in text. A tool using agent can be wrong in the world. It can send an email, query a CRM, pull a contract, schedule a meeting, modify a spreadsheet, create a ticket, delete a file, post to social media, trigger a workflow, buy something, move money, open a support case. That is why tool use needs a traffic controller. A good harness does not just hand the model a bag of tools and say, use whatever seems helpful. It defines a source hierarchy. For internal company data, internal tools should usually beat the public web. If the user asks about our Q3 sales deck, the agent should not search Google. It should search Drive, Slack, Notion, SharePoint, or whatever internal system is authoritative. For current public information, web search may be appropriate. For mixed questions, the agent may need both, internal company context and external market data. This is where AI agents start looking less like chatbots and more like junior analysts. An analyst does not answer a board question from memory alone. They check the latest numbers, compare sources, pull internal documents, and synthesize. The agent should do the same. But there is another layer, tool budgets. Some questions need one lookup, some need 5, some need a deeper research workflow. If an agent uses too few tools, it guesses. If it uses too many, it becomes slow and expensive. The harness needs to decide how much effort the question deserves. That is not just technical optimization, that is product judgment. There is a difference between retrieving information and taking action. Reading a document is one thing, sending an email is another, finding available restaurants is one thing, booking a table is another, drafting a social post is one thing, publishing it is another. This distinction is central to agent design. A good harness separates low-risk, reversible internal actions from high-risk, external, irreversible actions. It also protects user agency. If multiple third-party services are available, the agent should not silently choose one unless the user named it, selected it, or previously established a durable preference. This may sound like a small UX detail, but it is not. It is a trust boundary. Executives should ask their teams, where can the agent act without confirmation? Where does it need approval? What actions are reversible? Which ones create external commitments? Which actions are logged? Who can audit them? Engineers should translate that into side effect levels. Level 0, answer only. Level 1, read data. Level 2, create a draft. Level 3, modify internal state. Level 4, communicate externally. Level 5, commit money, legal obligations or irreversible actions. Different levels require different gates. The more real-world power the agent has, the less you should rely on the model's judgment alone. Many people still think of AI output as text in a chat window. But real work does not end in chat. Real work becomes documents, spreadsheets, decks, reports, code files, tickets, dashboards, diagrams, and emails. That means a production-grade agent needs rules for artifacts. When should an answer stay in line? When should it become a file? Where do uploaded files live? Where does scratch work happen? Where do final outputs go? How does the user access them? What happens if a file is too large? What happens if a document format requires special handling? This may sound operational and boring, but it is exactly where many AI products break. The user says, create a report, and the agent writes a beautiful report in chat, but the user needed a downloadable file. The user says, fix this spreadsheet, and the agent describes how to fix it instead of actually modifying the file. The user asks for a PowerPoint, and the agent gives an outline. That is not an intelligence failure. That is a harness failure. The harness must translate user intent into an output modality. Chat, file, visualization, code, workflow, or external action. Each one needs different machinery. Here is a painful truth about many agent systems. They appear stateful, but they are actually improvising. The transcript grows, the model sees some previous messages, everyone assumes the agent knows where we are. Then the context gets long. Something is truncated. A tool result is forgotten. A user preference disappears. The agent repeats work, misses a constraint, or contradicts an earlier decision. For simple chats, this is annoying. For enterprise workflows, it is dangerous. A serious agent needs explicit state. What task are we doing? What has already been completed? Which files have been created? And how about the current active assumptions? What tools were called? Are there any approvals are pending? What risk flags are active? Do we know what needs to happen next? Think of this like air traffic control. Planes do not simply fly around because pilots remember the conversation from 10 minutes ago. There is a shared state, altitude, heading, route, clearance, weather, runway assignment, traffic, fuel, emergency status. Agents need the same discipline. The conversation is not enough. The harness should maintain task state, tool state, memory state, risk state, and artifact state. The model can reason over that state, but the runtime should own it. For executives, the lesson might be quite informative. Do not evaluate an AI agent only by asking, how smart is the model? Ask how the harness works. With normal software, you evaluate features. Does it have the dashboard? Does it integrate with the CRM? Does it export the report? Does it support the workflow? With AI agents, that is not enough. An agent is not only a feature set, it is a decision-making system. So the first thing to understand is where its reality comes from. Is it answering from the public web, from internal documents, from memory, from a database, or from a mixture of all of them? More importantly, does it know when that information may be stale? A brilliant answer based on old information is still a bad answer. Then comes the question of power. What can this agent actually do? Reading a document is one level of authority, editing a document is another, sending an email, posting online, changing a customer record, approving a refund, or triggering a workflow are different categories of risk. A mature agent should not treat all tools equally. The moment an action affects the outside world, the harness should know whether confirmation is required. Memory needs the same scrutiny. It sounds useful when an agent remembers your company, your style, your projects, and your preferences. But memory can also be incomplete, outdated, or unsafe to follow. A good harness does not blindly inject everything it remembers into every conversation. It filters memory the way a good executive filters context before a meeting. What matters for this decision, what is sensitive, what is outdated, and what should not influence the answer at all. Outputs are another part of the system. The agent should not simply produce confident language. It should know when the right deliverable is a chat response, a file, a spreadsheet, a deck, a diagram, or a draft waiting for approval. It should also have a way to check its own work before handing it back, especially when the output will be used outside the conversation. And finally, executives might want to stress test how the agent behaves when reality gets messy. What happens when the tool it needs is down? What happens when the user gives an ambiguous instruction? What happens when two policies conflict? What happens when the business goal pushes in one direction, but compliance pushes in another? That is where the quality of the harness shows up. A demo agent looks good when the path is clean. A production agent earns trust when the path is not clean. When data is missing, permissions are limited, tools fail, customers are angry, incentives are misaligned, and the safest answer is not the fastest answer. That is why the real buying question is not which model powers this agent. The real question is, what kind of operating system surrounds it? These are the questions that determine whether the agent can survive contact with reality. A demo agent can impress people in a meeting. A production agent has to behave correctly on a bad Tuesday afternoon when data is missing, a customer is angry, the policy is unclear, and the tool it needs is down. That is where harness engineering matters. For engineers, the practical takeaway is this. Do not put everything into one giant prompt and hope the model follows it. Some behavior belongs in the prompt, but a lot of behavior belongs in code. Tool permissions should be enforced by the runtime. Memory retrieval should be filtered before context assembly. Sensitive actions should require confirmation outside the model. Output validation should happen after generation. File paths and artifact rules should be deterministic. State should be stored explicitly. Policies should run before the request, before tool calls, after tool calls, before the answer, and after the answer. The model should not be the only line of defense. The model is excellent at reasoning, synthesis, language, and flexible judgment. The harness should handle structure, permissions, state, validation, and control. That separation is what makes agents reliable. It is the same reason airplanes have both pilots and instruments. The pilot is intelligent, but the aircraft still needs mechanical systems, warning lights, checklists, and autopilot boundaries. Intelligence without instrumentation is not reliability. The leaked prompt, real or not, gives us a glimpse of where AI systems are going. They are becoming less like autocomplete and more like operating environments. The prompt is no longer just a personality layer. It is a constitution, a routing table, a tool policy, a memory policy, a file handling manual, a citation guide, a safety framework, and a runtime contract. That tells us something important. The next generations of competitive advantage in AI will not come only from access to powerful models. Those models will keep improving, and many companies will have access to the same frontier capabilities. The advantage will come from the harness. The companies that win will be the ones that know how to wrap intelligence in process. They will know how to give AI agents enough freedom to be useful, enough context to be accurate, enough tools to be productive, and enough constraints to be safe. That balance is the whole game. Too little freedom, and the agent becomes a chatbot with a fancy title. Too much freedom, and it becomes an intern with admin privileges. The harness is what turns the model into a trustworthy worker. It is what turns raw intelligence into operational capability. So the next time someone shows you an AI agent, do not only ask what model it uses. Ask what harness it runs inside. Because the model may be the brain, but the harness is the body, the nervous system, the seat belt, the steering wheel, and the brakes. And in the real world, brakes are not optional. What are your thoughts? Comment on this post and let's start the discussion.